The goals of our team are initially to just build an autonomous underwater vehicle that is able to function at the rowboat sub competition. Beyond that, we are a learning team. So our long-term goal is to develop well-educated engineers that are able to speak up for themselves and work well in team environments.
So in the past, our overall designs for the AUVs have been pretty successful, and as the years go by, we've just been working on perfecting them. Every year on AUV, we go through a design phase and then a fabrication phase. And this year we're going to be able to have a testing phase.
The overall design and development process for the entire team is to brainstorm, iterate, finalize, and manufacture. During this process, it's a lot more interactive than just the theoretical exercises in class because we have to keep accessibility and manufacturing in mind.
For the electrical sub-team in general, when it comes to design and development, we really started by looking at last year's vehicle and what went wrong at competition, and then from that I think we can make a better design and improve upon what we had.
So this year I'm really excited that we're going to be able to perfect last year's robot, which in turn built upon the robot of the previous year. So we're going to be able to perfect our mid-cap, our bottom panel, just make everything the way that we learned it should be from competition. Over the past couple of years, we've been pretty successful as far as the overall design of our robot, but each year presents its own unique challenges. So this year we're focusing on perfecting the little things of last year's robot.
I have quite a few expectations for this year because we do have a lot that we want to implement.
For this year, our technical expectations are to upgrade the internal components because we have luckily been gifted a Jetson, which is a new processing component, and it will allow us to become more accurate with our buoyancy because from that, we are able to use more of our budget to allow us to, for instance, upgrade our cameras so we spend less space on converters and we are able to make the buoyancy more efficient.
Some technical expectations I have for this year, specifically for the programming sub-team, is implementing ROS, which is a robot operating system. In addition, we are also looking into implementing a vector nav, which helps our vehicle know where it is and the position of the vehicle in the water, which is really important and would be really useful for our competition.
This year's vehicle is a lot more ambitious than the other years because initially we set out with the goal of just redesigning the frame every year to give everyone an equal opportunity for the experience. However, we realized that the manufacturing experience could also be applied to the mechatronics components. For instance, instead of just learning how to use CAD programs to make a base plate, we are using those skills in order to teach how to make a ball dropper or a claw or something that will be able to earn us more points than just swimming straight forward. We are able to reach out for more points and earn a more competitive edge this year. This year we're keeping the overall frame structure the same. If you look at the silhouette between the past 2 years, it's very similar because it's sturdy and it works. So we are able to build off of that instead of brainstorming from the beginning in order to push the boundaries of what we are capable of and just learn what we can do.
So this year we have an NVIDIA Jetson that was donated to us, and it will not fit in the current mid-cap, so we actually have to modify one that we used 2 years ago. So this year we're also modifying our bottom rack panel that has more precise placement for each of the components that we want to put onto our bottom panel. Last year we used a more modular design, but we're thinking that this year modular isn't the way to go for us. In order to accommodate our new cameras, we have to create new end caps that have a hole in them so that the camera can see through our housing. We're doing this because the camera itself is not watertight, and so rather than creating its own watertight housing, we're just going to put it inside the hole.
We were met with a lot of challenges, especially this past year and especially even just at the week of competition. One of those challenges was dealing with power. When we got to competition, our processing system gave out on us. There's quite a few different reasons why this could have happened, but I do think one of the issues was with power distribution. So what we wanted to do was we wanted to give it more voltage. So instead of giving it 12 volts like we had been, we wanted to give it 19. So what we did was we put 2 batteries in series, and that gave us a total of around 30 volts. And then we also had to implement a step-down converter to give us around the 19 volts that we wanted. And this worked for competition, but it was more of just a band-aid for that kind of week-long event because the voltage converter does tend to overheat a little bit. It's not good for the long term, but obviously the power supply system that we had been using is not going to work either. So that's one of the difficulties that we have been really trying to work with, just coming up with a steady way to get power where it needs to be. Instead of using the analog cameras that we were using, which were for the forward-facing cameras that we had, we're going to use a new camera system that we got that is going to be placed inside the vehicle. It also is going to come with stereo vision, which should be helpful for our programming team, hopefully. And then it also comes with an IMU, which is a new sensor that we can work with and hopefully get some good data off of and be able to implement some pretty cool things with that as well.
Some challenges we faced in programming is that we were able to get our object detection working, but we were not able to get our vehicle to track our object and react to what it saw. To address those challenges, we are using ROS, as I said, the robot operating system, which will help us have a management system for our robot and basically allow us to take in a bunch of sensors and take in all of that data and have our vehicle react to the sensor data.
Our main successes have been to transfer information between class years and just accumulate an understanding of the process as a team. For instance, the logistics organization is much more streamlined than it was initially. You can see that throughout our documentation and just between the interaction between older and younger members of the team.